Hello. Thank you very much. So I'm Vicky Faulkner. I head up business development for big data and analytics out of Melbourne, but I actually lived in Canberra for 10 years, so it's really awesome to be back. I get to go have dinner with friends tonight, which is really nice. In putting this session together, what we thought we would do is we would try and talk you through a typical sort of customer story. So we see lots of customers at the moment who are trying to take themselves on a journey in terms of re-architecting their data platforms. And so what I've put together is a fictitious story, but it's a pretty common story around how our customers go on this journey. I'm going to take you through that for about 20 minutes, and then I'm going to hand over to Peter James. He's going to take you through a real story of a customer actually sort of re-architecting a data platform to generate sort of value at scale. So I hope it's a really useful session for you guys today. So this customer that I'm going to take you through is completely fictitious, but they have a lot of commonality in terms of the approaches and the way that we see customers doing things. In some ways, this is a little bit of a best practice guide in terms of your approach to what data and analytics sort of looks like. So here's my fictitious company. Please bear with me on this. They're called Audible Ears, and they've been a traditional supplier or manufacturer of hearing aids. So they have manufactured hearing aids, they've sold them to distributors who've then gone and sold them to retailers. So they've really had no interactions with their customers, with the end consumers of their products. Moving into 2016, they've updated some of their technology and they actually have an app now that interacts with their hearing aids, which is sort of awesome because it enables the person using the hearing aid to change settings, to get recommendations for better settings, and they've even prototyping some really cool things like voice-to-text translation when they can't hear properly, and a music streaming service. Like I said, bear with me. This is this is a fictitious sort of example. So as a customer starts out on this sort of journey, we tend to solve for two types of people. So typically, we would be solving for people like a head of finance and a head of product. So in my example here, I have Lim, who is head of finance, and she is trying to answer questions like how does quality affect production, and what does supply performance look like over time. And I've got Raymond, who is looking at things from more of a customer perspective. So how are customers actually using the new features that I've built into a product? And something new for him is along the lines of what is social sentiment about our product, something they've never been able to actually get a gauge on. These two roles are really interesting, and a big part of the approach we see in terms of designing platforms is actually thinking from the end user persona perspective, which is quite different to the way I think we've done things in the past. So we spend a lot of time working with the end user of a data product or a data service, trying to figure out actually how they want to do things. When I think about traditional builds of data and analytics platforms, we've spent a whole lot of time trying to figure out what we're going to need 2 to 3 years from now. We try and predict what that's going to look like, and then we've always had to buy huge amounts of capacity or boxes actually to deliver off that. So this is a much more agile iterative approach where we'll start with just a few questions that our end users are trying to do, and we'll build those out in a really quick iterative manner to see if there's value in the data and value in the way in which we build. So what we'll do is we're going to start by building the smallest possible pipeline to answer questions for those two personas. So rather than making that big upfront commitment, we're going to build a really, really thin pipeline, pulling in the smallest amount of data possible, doing some analysis and processing on that data, and then enabling that through some sort of visualization or some sort of consumption method. Now we can then take that back to that user and show them what we've developed, hopefully in a really, really rapid manner, and we can get some really quick iterations and feedback as to whether it answers the questions of Lim and Raymond. So we put this basket of sort of use cases into the category of what I'd call modernize and consolidate. So we're really going from customers who have existing data applications on-prem, and they're trying to figure out how do we do this at scale, do it faster, pull together silos of data. But we're really just doing a sort of a small uplift in terms of the value that the data and analytics is providing. So we'll go back to Lim's problem. She knows that in order to answer these questions, the data probably exists in two systems. So she's looking at order history and returns from her CRM system, and then she knows that there's some good data around inventory holding in her ERP system. So what we're going to do is we're going to build a pipeline. So really simply, we're going to ingest some of that data into the smallest possible pipeline. Oops, and I can't go backwards. We're going to ingest some of that data. I'll show you how. One of the key concepts here, though, and one of the things that we're continually talking to customers about is this idea of start small and iterate, which again, I think is really, really different to the approach that we've taken in the past. So again, we're not going to think about what we need 2 years from now. We're going to think about the immediate requirements of my users, and I'm going to build to that in a really fast, iterative manner and see if there's a value in that. So this is LIM's pipeline. We're asking for the smallest amount of data. In this case, we might be pulling some data out of something like Oracle Financials. Now, I've been given a couple of things from the business, in the sense that they don't want me to spend too much time playing with those ingestion sources. They want me to interfere as little as possible. So we're going to use some existing tools to try and extract that small amount of data. So we'll use something like a data pump to get the data out of the Oracle financial system. And then on the SAP side of things, anyone who's ever looked inside SAP knows that it's pretty complex in terms of the schemas and structures that sit in there. So in this case, we might use something like Bright. Now Bright are a technology partner of ours. We have a lot of technology partners, but these guys have some really interesting tools that help you extract data from SAP. So in this scenario, we're going to use those two tools to pull the data out, and we're going to land it in its raw format into a raw data platform, or a raw data lake, actually in a raw data area on S3, which is the Amazon Simple Storage service. Then we'll do a little bit of manipulation, curation of that data, and we land that into our data lake. And again, that data lake sits within S3, and we'll make that available to the end users in the tooling that's appropriate to her. So in my example here, Lim is, she's an analyst. She uses a tool like Tableau. Another requirement from the business was that they didn't want to actually have to relearn new tools. So don't touch my source systems too much, and don't make my users learn new tools, but give me some agility to get to that data really, really quickly. So she had a couple of questions. One of the sources of data she was using actually had dimensionality around it. So what we might do in that case is load it into a data warehousing platform like Redshift, and I'll talk a little bit about Redshift in a moment. The other question she had was around what was happening in some of the warehouses, and so we might have some log data that's coming out of either a manufacturing plant or even off a warehouse. Now that's not the sort of data you'd end up putting into a tool like Redshift, but you might want to do some analysis on that through a service like Athena, which lets you query against that data directly. So she's got a couple of tools she can start to play with to look at the data that's actually being loaded into this data lake for her. So a little bit about Redshift, just to give you a sense of what it is. Redshift is it's a modern warehousing platform that was built for the cloud with the cloud in mind. So it is super fast to scale. You can start with literally gigabytes of data, but scale it all the way up to petabytes of data, and pay commensurately for actually what you're using. So it was always built with that intention in mind. Open file formats that enable you to access the data, and it pulls all that data from S3. So something that you're going to see in common as we go through this, that S3 is that storage service, that data lake, becomes that centralized repository from which a number of different analytics tools or analytics engines can draw data. One of the key themes I see going forward is, I think in the past, as we've designed data platforms, we've always designed it with an analytics engine in mind. So we've been building a warehouse, and that's the thing that everyone was going to access. The key theme I see going forward is stepping back from that and thinking about data and keeping data in an open format that's accessible to lots of different analytics engines. So I may have one use case for the likes of Lim where I want to put that into a warehouse because that makes sense for her use case. I may have other users who actually want to look at that data directly, and so they want to be able to pull that data from S3 and use the appropriate tool. I may have some data scientists who want to get back to raw data. What I don't want to be doing is reconstructing data out of my warehouse environment. I want to be able to get to that data lake where all of my data has actually been stored. The other important thing is security. So Redshift was designed from the ground up to enable encryption of everything from the moment we started building this tool. And finally, it's super cost effective. So, we estimate it's about the 10th of the cost of a traditional warehousing environment. So a great place for people to start as they start to think about their warehousing requirements in a cloud environment. So I've touched on data lake, and I just want to build this out a little bit more. The idea with a data lake is that you can store everything. So even if you're only thinking about more transactional or ERP data today, tomorrow you might start to think about log data or geospatial data or voice data, if people who were in the previous session around Alexa, or even machine vision data. You want to be able to store that in a way that's cost effective, with a view that there might be some value in the analytics that you can do that in that data across time. You want to be able to enable all those different personas, those different users out in your organization, to get to that data when they have a question around that data. They have a hypothesis and they want to run an experiment. You want to make it really, really easy. I'll give you a good example. I was talking with a client in Melbourne just recently, and we had one of our data science team there, and they were asking about, should all their data sit in the data warehouse or should it sit in the data lake? And his answer was, look, if all your data is in a warehouse, it's probably going to take me 3 months to kick this project off. If all of your data is sitting in a data lake, then I can get started next week. So the raw data is there. For the particular problem he was trying to solve, he wanted to get back to that raw, original sort of set of data. Flexible access, and I've probably said this a couple of times, but you don't know how people are going to use that data. You don't know, standing here today, you don't necessarily know the analytic tool that they are going to want to use to access that data. So enabling lots of different access mechanisms is super, super important. You have users who are really comfortable with the BI tools they use today, and they might want to continue to use those. You also don't know what tooling's coming along. We live in a time of incredible change and evolution, particularly in the machine learning space. So that ability to actually future-proof the data you're storing today for some great new technique or algorithm that might come along in the future is really, really important. So think really, really strongly about actually keeping the data that you have, that really vital asset, in really open format, so that's reusable at the time that you actually need to use it. So we have Raymonds Questions. So he was interested in, what features are my customers using, things like demand forecasting, figuring out demand today and projecting that into the future. And he had this question around social sentiment. Now, because LIM has done that first project, some of that data is now sitting in the data lake. One of the things that we don't suggest is, we're not saying pull every piece of data that you've ever generated into your data lake. You actually don't want to create a data swamp. You want to be putting data that is of value and value to your organization into these platforms. So in our first use case, we've popped some data in there for Lim to answer her questions. Some of that's now available to Raymond, but there's some additional data that he's interested in. So he's interested in this idea of social data. So we'll do some analysis. So the way we'd like to think about this is run some quick experiments on that data, see if there's value in it, and if there is value, then push that into your data lake environment. So here we go. So I'm just going to keep adding to this slide. So we have our data coming from our ERP systems. We've now got some social media data that's coming in to answer this next question. So this data is sort of streaming in, and it's coming through a service called Amazon Kinesis. So we don't stream that data directly into the raw data area of S3. When you're streaming data, not all events sort of come in the right time. There's some windowing, and there's a bit of manipulation you need to do on that data. So we use Kinesis to do that, to do a little bit of curation, and then we dump it into, I shouldn't say dump, we push it into the S3 platform, do that curation of data, and then push that out to that data lake if that's of value to Raymond. Now, Raymond is not a data analyst. He needs some really simple tools to actually get to the data. So in this case, we're loading that into Redshift to do some front-end dashboards and stuff. I've got him using Amazon QuickSight, but that could be any third-party tool that he's really comfortable with. So it could be a Tableau, a Click, whatever makes sense to him from a productivity perspective. The other thing here, because we have some, I guess we have this sort of log or streaming data coming off social sentiment, there's a service called Elasticsearch, which is awesome for doing textual type search across really, really large logs. And again, he's using something like Kibana at the front end to actually leverage that. Here, I'm just trying to give you a sense of for every every problem, there might be a different set of services or a different set of tools that you actually want to leverage to answer the problems that you're trying to get to. I think the days are gone where we were locked into a certain suite of tools. The beauty of this sort of the way we see platforms coming now is you can apply the right tool and the right technology to the problems that you're actually trying to solve, and you can do that, incredibly quickly. It's really, really, I think it's really powerful in the way we move forward with data and analytics. Okay, so I've talked a little bit about pipelines, and I just want to dig into this a little bit more. So we push raw data into Amazon S3. Once it lands into S3, we trigger some Lambda code. So we see that, an object is changed. We want to do something with that data. So we want to do some aggregation or some analysis of that data. And actually, Peter will talk about some examples of what they do shortly. So in that case, we spin up an EMR cluster. In this particular case, we spin up an EMR cluster, which is great at doing sort of ETL type things. We generate that, and then we load that curated data back into S3. Down the bottom here, we're capturing some information about that data. So the metadata about that data, the lineage, where's that data come from? How can I create a catalog of that data so that my end users actually understand what is sitting inside my platform? And in this case, we've pushed it off to Redshift. But as I said, that could be any number of other services that enable sort of visualization or consumption. The beauty of this sort of scenario is they're all decoupled from each other. So you're not trying to make a decision on how much you need. So we have great examples. And in fact, for anyone who just sat through the keynote, they talked about FINRA, which is one of the financial regulators. Literally, when it comes to end-of-day processing, they're looking at all the trades that have come through, and they're looking for examples of fraudulent sort of trade or money laundering, those sorts of things. They will literally get to the end of the day, and they will spin up EMR clusters that are thousands of nodes, process for a couple of hours, and then turn those off. So no longer do you have to have that big set of compute sitting there and available. You scale out to what you need at the time you need it, and then you scale back down. Oh, sorry, I'm just going to move through this because I'm running a little short. Hold on a second. So I'm going to simplify this. So we have basically we have two ways of streaming data through. So we have our data pipelines here, and at the bottom I'm going to start to look at an event pipeline. So this is when we start to do things in real time. So the second outcome we see people looking for once they start to build out their platform. So they've gone through this we're going to do a bit of modernization and consolidation. We're going to start to innovate for new insight. And the sorts of questions you might be wanting to ask are things like, how are consumers actually using my hearing aids in this particular case? When do they turn them off? What times? They're changing the settings throughout the days. What kinds of people are increasing usage? You can think of lots of really interesting use cases if you could get those logs off how this device was actually being used, and any medical device to be of interest. Could we predict things like hearing loss from the way people are using the application? There are some awesome insights you could get, as a data scientist if you start to have a look at that data, particularly longitudinal data across that. So there's some interesting things we could do. So again, we work backwards. So we start with the questions that my end persona is trying to answer, and we work backwards to what data do they actually need. So in this case, we might have some registration data. So people have got a hearing aid, they've registered on the app, and then we can grab a log of actually how they're using that. This is where you've got to bear with me in terms of my stretching my example from a customer perspective. But we could be using an API like to a third-party music service, and again, we can capture data from that and see if people are using this. So this might be a prototype that we decide to run as Audible Ears to see if, actually, is there something we can do for people who are impacted by hearing that we can make their music listening experience, even better. Again, for us, it becomes another source of data that might be able to give us some really interesting insight into how our hearing aids are being used, but also how we could improve them into the future. So, I don't know why those things are there. So, we load this data into the data lake. We have some other data. I talked a little bit about voice to text, so maybe we have another prototype where we're thinking about, again, if you've got people who are having problems with hearing, one of the useful use cases for them might be in some circumstances, actually we do some voice to text translation. So we have some of these services available. But Christoph, who's playing with this, doesn't know whether that's data that should end up in the data lake. Again, this idea of not creating a swamp, you only want useful data sitting in that data lake environment. environment. So he wants to be able to run some experiments to see if there's actually value in the data that sits there. And the idea of sandboxing is just something that's, it's incredibly powerful in the Amazon cloud environment. This idea that, I'd really like to play with a service like, I'd like to be able to, I have a question that I want to answer around usage. I want to be able to spin up a sandbox. I want to use a tool like SageMaker to see if I can make some predictions around the usage of my service. So don't take anything else away from today, just this idea around experimenting and sandboxing is super, super powerful. So I've put another box in here, and this is sort of in between our raw data, where we initially land raw data, and pushing it into the data lake. And this is where Christoph is going to spin up his sandbox to try and answer a question. And we'll go with a really interesting one of, if we have enough historic data coming off the devices, can we do any prediction around how, maybe people's change in the settings that they have on their hearing aids, and are there any indications that means their hearing is changing, or, they're increasing hearing loss. So what he does is he spins that up as an experiment. Maybe he proves out there's actually some value in that. And so when you've built some sort of algorithm that shows that there's value, what you might end up with is a data set that you then push into the data lake. So that data set might give you a prediction that this 10% of users actually seem to be having some problems based on the way they're using the hearing aids, and maybe we need to contact those people. So I'm just going to make that a little simpler for you. The third outcome we see people moving towards, they go through modernization and consolidation, they start to think about what they could do from a predictive perspective, and then they begin to think about real-time engagement. So everything we've done till now is sort of in a batch sort of mode. And so we're starting to think about how we can personalize things in real time. And I'll take you through a really, really simple example here. So say I've got my hearing aid in, and I want to interact with my phone that says, actually, I'm sitting here in the theatre and I want to know what the best settings are for me. So you could use a service like Amazon Transcribe or Comprehend to actually ask that of the phone. And effectively what you're asking for is a recommendation, and the category is theatre. So we would assume that using that data lake, we have a historic view of the sorts of settings that are best used in those circumstances. And so we're going to send those settings back to our end users, back to our end user who's actually got that device. The other thing we could do in this case is actually look at the GPS coordinates. Again, just bear with me, but these are the sorts of things that we start to see people doing. Once they land data into the data lake, they start to have these great ideas around better ways they might actually be able to use it, and they can sort of create these hypotheses and run with these experiments. And you might go, actually, that's, nobody is interested in that. But if you can scale these up fairly quickly, test them, and then if they do work, then you scale them out. But if they don't work, you turn them off. And I think that's the incredibly powerful thing about these sorts of environments, that ability to run fast experiments in a really agile way and just work with the ones that have shown you some value, and then move away from the ones that don't. And it really doesn't cost you anything other than the time and the small amount of compute that you've actually used in delivering those. And so over time, you start to build up a history of these sorts of use cases, and you might see other people doing similar things. So your recommendations actually get better and better over time. So this is just to give you, I guess, a really high-level view. So we would use our, Christoph would use his ML sandbox to build out a model that makes certain recommendations. Those recommendations could then be built into our event pipeline. So when someone comes in with a particular request for these settings, that prediction or that recommendation could be run in real time and passed back to that particular user. And those actions of those might go out to some sort of engagement platform, or it might, go back directly via one of those AI services. So it could be something like Alexa that you're actually using within your application. So I've just gone through three sort of outcomes and three sort of stages that we see customers going through. So the first one being modernizing and consolidating. The second one, this innovation, so beginning to be able to do things like predictions across data. And that third one, there's really real-time engagement. And I would really suggest that you start in this way, like building out that real-time engagement engine to begin with is probably not the best place to start. You need to prove out the value and prove out the technology capabilities over time. It makes a I would say I see far more success in people who approach it in that way. So, in terms of getting started, I would absolutely say we run a lot of workshops with customers around just short listing the ideas that they have. So come up with a list of ideas where you could get value that you're not getting today. I always run those with business end users. What are the things you can't answer today that will make a difference to your organisation? And figure out which ones are going to give us the biggest value, but you can start with early. And we typically run those in like 4 to 6 week POCs with customers. Build those simple pipelines that you can iterate and build on and build out the data that sits within your data lake environment. And then thirdly, just ask us. We have a whole lot of very smart people within AWS, particularly the solution architecture team, who can absolutely help you to get started in terms of building some of these early sort of use cases. So if you need any assistance, absolutely feel free to reach out.